Breaking the Wall of Real-Time Processing. Dorothea von Bruch. Falling Walls Lab, Tokyo.
I need to break the wall of real-time processing to answer one of the most fundamental questions that relates to all of us. Why are we here? Why are we, who are consisting of matter, here if modern physics cannot explain how matter emerged from the Big Bang? In particle physics, we need to understand where this tiny asymmetry between matter and antimatter came from that must have existed very early on in the universe. To do so, we perform high-precision measurements of the properties of particle interactions and compare them to the prediction of the currently known theory. Intriguingly, in recent years, we have actually seen some deviations between the measurements and the predictions. However, the current data samples are not yet large enough to really claim a discovery of possible new physics that could explain this deviation. Therefore, we need to observe many more particle decays and their properties to really find out, is this new physics that we're seeing? Therefore, at the LHCb experiment at CERN, where I work, we are analyzing 30 million particle collisions per second now to really reach the required precision that is needed to understand what these deviations are consisting of. However, we face a wall. The wall is processing this data that is produced in real time. To give you an idea, the largest internet exchange point worldwide is located in Frankfurt and processes 14 terabits per second of data. At my experiment, we have to analyze 40 terabits per second of data. This is no longer possible with the systems that we have been using until now, based on traditional CPU processing architectures. Instead, we need to use modern architectures such as graphics processing units, short GPUs. GPUs were developed to display images on the screen. You might know them from video games, and they are the workhorse of today's high-performance computing centers. So we transfer this knowledge now and this technology to fundamental science. Within a team, over the last few years, I have developed a software framework and the algorithms that are needed to analyze our 30 million particle collisions per second in real time using only 200 GPUs. It is the first system of its kind in particle physics, and we are breaking the wall of real-time processing to perform precision measurements starting from this year on with the LHCb experiment. It is even up to 2 times more efficient in selecting the processes of interest that we are interested in. So with this, we can now perform the precision measurements and understand what is the type of new physics that we might be seeing to get one step closer to answering the question, why are we here? Why is there matter in the universe? Thank you very much.